Hello, and welcome to the short video on how to find a critical z-value using Desmos. So in my videos, you've seen that we are learning to find critical z-values to help us with confidence intervals. And I have mentioned this table in our formula packet and how when you find your alpha divided by 2 or any alpha, this will give you the area to the right or the left because a z normal distribution is symmetric. So the same area to the right is to the left and they're equal. So a positive z on the right is going to be equal to a negative z on the left. And so you can find your area. So let's say we are looking to find a 95% confidence level. So we have 95% of our data should be in the middle. So our alpha is going to be 1 minus that decimal, or 0.05. And because a confidence interval means that we're going to have half of that extra area to the left and half of that extra area to the right, we must divide that alpha by 2. So we are really looking for 0.025% to the left and 0.025% to the right. And we want to know what z-scores go with that, with those areas. So we can go to 0.025 on our table. Right here it is in the middle. And we're going to go all the way down. And I suggest that you write these same alphas on the bottom because your z is the very bottom row. Remember, we're using the table up here for the t-scores when we use the t distribution. But the z distribution never changes. It's always following these values. And so 0.025 goes with this right here, 1.96. So z equals a negative 1.96 is symmetric with positive 1.96. And they both associate with 2.5% to the left and 2.5% to the right. And you'll see that this is very typical of what we've been dealing with earlier in the semester, where we just had one set rule that we used to decide if an observation was or an outcome was considered unusual. So we always said an outcome was considered unusual if it was above 2 standard deviations above the mean, which is almost 1.96, or below the mean by 1.96 or 2 standard deviations. And that you can see is associated with a total of 5%, 2.5% on the right and 2.5% on the left. Okay. Now you can also find these in Desmos because our table that we're using doesn't give every alpha divided by 2. You may have one that does not, is not in our table. But let's go and show how we're going to find, how we can find the one from our table right here, our curve in Desmos, so that you can see this. There is in our Canvas course, you will see a link that's called Critical Z-Scores in Normal that I made for this. So if you want to find the area to the right of a Z-score, you're going to use the normal distribution. The normal dist where the mean is 0 and the standard deviation is 1, because that is how we defined the normal curve back in chapter 6.1. So if I put in, I will always hit my magnifying glass here too. So we can see that area to the right is in red here. So I'm going to put what area or probability is to the right of 1.96 standard deviations. And that means I'm going to have a positive infinity to the right. And that's this area right here where I'm using my mouse. If I want to find the area to the left of a z-score, then my z-score is going to be the maximum value, and I will have a negative infinity. And that is also about 2.5% to the left, and that's in purple. Now, what if I know the area and I want to find the z-score that matches it? So if I knew that I wanted to find the z-score that goes with 2.5% to the right or to the left, let's do the left first. If I wanted to find the area to the left because of my alpha divided by 2 for my confidence interval, then I'm going to use the inverse CDF of the normal distribution, and I'm going to tell it the area to the left is 0.025, and it will give me a negative 1.96. If I want to know the area to the right, then I'm going to use 1 minus that, because I put in a note here that with inverse CDF, you must always use the area to the left. That's how it works. So if you're finding an area to the right, you have to use 1 minus that area, and it will give you the positive z-score. Now, let's go back and do one that does not follow along with our formula packet. So let's say we're doing a 93% confidence level. So my alpha is equal to 1 minus 0.3, which is 0.07. So my alpha divided by 2 will be 0.07 divided by 2, which is 0.035. So that means I'm going to have 0.035 area to the left. I will have 0.035 area to the right. And I will have 0.97 area in the middle. And I want to find the symmetric positive and negative z's that go with that. So we're going to go to desmos, and because I want to have, this time I want to have 3.5 to the left, I'm going to put in 0.035, and I will find out that that means that my z is a negative 1.81, and then I could go down here and do 0.035 and find out I have a positive 1.81. And we can even make that match if we were to go up here and see it on the curve and do 1.81 to the right, it will give us, it'll tell us it's 3.5%. And we can see that on the graph. So we can see on our curve that we drew that the z-scores that go with this confidence level of 93% is 1.81 and negative 1.81. Let's be back for some other short videos.